In the recent years, there has been a lot of talk about 5G. We talk about its potential, how it will support the IoT infrastructure, how it will increase internet speeds exponentially and offer new opportunities for smart cities. We also hear a lot of uncertainty about what 5G really is, and this lack of clarity has, at times, caused some more curious theories about 5G. One of the main goals of Smart City Experience is to help demystify the different elements that make a smart city, which would enable decision makers to be better equipped to plan the future of their municipalities. To help us shed light on what it takes to implement a 5G infrastructure, I would like to welcome Yann Benoit, Territory Manager, Eastern Canada, Wireless Access Network Operations for Bell Canada, to join with me on the virtual stage. Hi, Yann, and
Hello, how are
welcome.
you? Thank you very much.
I'm good, thank you. So
Excellent.
this is a very long title. Could you explain to me what it is exactly?
Very simple. A bunch of geek engineers. What we do, we plan, we design, we build, and we maintain the wireless network so that you guys have fun with these things, right? So that's what we do.
Thank you. And now the stage is yours.
Thank you very much. So welcome, everybody. This afternoon, we're going to talk about 5G network technology, but really from the point of view of the operator, right? We hear many things about marketing, about generating revenues and stuff like that. But for an engineer, managing the network, what is it? So basically, that's what we will do. We'll talk about the what is it, what we want from that network to offer our customers, the why do we need that? Why do engineers need to build this kind of network for the customers? And the how. Today, 2020, you guys are seeing announcement popping up that 5G is here and there. How do we do it right now? So this is what we're going to cover. So let's start with the what. From my perspective, the expectations of 5G are summarized here. And I'm going to go clockwise on this circle. First of all, we want this network to be 99.999% available. So what does it mean? It means simplifying the network and making it as reliable as a fiber, an optical fiber. So wireless being as good as wireline in terms of experience. It doesn't matter how the customer is connected, the experience needs to be the same. If I continue 100% coverage, that means a few years ago, we developed our 3G network. After we deployed the 4G network, an existing, exactly on the same overlay, so same coverage, 5G needs to have the exact same coverage again in terms of covering almost everybody. In fact, 99% of the population, that's the case for our network. 90% less energy. So here, it's not from the cell site point of view, not from our electricity point of view yet, it's from the device point of view. The language or the protocol is written so that it's going to consume way less energy because we need way more battery. We need batteries to go and last as long as 10 years. It's not the case right now, but it's going to be super important when, as an example, we're putting sensors in the asphalt to detect if there's a car parked there, right? You don't want to go and change that 5G sensor, change the battery every 6 months. So battery needs to last very long. Devices. This network needs to be able to support up to 100 more devices or connections by square kilometers. And we'll get back to this. Why do we need to handle more? 4G network is good for now, but you'll see that there's an explosion coming, and we need that. 1,000 times more bandwidth. So for us, the bandwidth, we communicate through frequencies or through a channel, right? And this technology is made to be able to handle wider channel, just like a highway. We need to pass from a highway of 2 lanes to a highway of 100 lanes, right? To enable ultimately more speeds, because the channel bandwidth that we use, actually I'm talking to you with audio with the channel bandwidth very limited, 300 hertz to 3000 kilohertz, something like that. So wider channel of frequency for cell phone communication to crank up speeds. So speed need to go up, not now, but in sequence go as high as 20 gigabits per second, which is amazing, right? We'll get there and I'll come back to this. Ultimately as well, the latency. So what's the response time of a packet going on that network? If I control a drone and that drone is 500 kilometers away, I move my joystick, 1 millisecond and it's done, right? Response time, super responsive network. Actually, we're between 20 and 40, 50 milliseconds, to give you an idea, right? So that's what we need. Excellent. We're putting the blocks together so that it's possible. Why? Why do we need this? This graph tells you our biggest problem, let's say. This is the growth, projected growth of traffic on cellular network just over 3 years, right? So imagine in a town, I would tell you that in 2023, you'll have more than 200% more cars in your town. That wouldn't be sustainable, of course. This is what we need to manage. It's coming, whether we move or not. This amount of network is coming. And where does it come from, really? It's coming from mainly streaming. So video streaming, audio streaming, and now streaming are becoming more complex. Evolve 4K streaming is there. So that's bringing a lot of traffic, and it's exponential, right? New applications also, connected homes, connected cars. Many cars are already connected on the 4G network. Augmented reality. You saw Google Stadia or the Microsoft X project. So for gaming as well, all through networks, it's moving very, very fast. Speed test. That's a speed test that I'm showing you that appeared. We did that speed test maybe, I don't know, 5 years ago. We could push something like 7.3 megabits per second. 5 years ago was not bad, right? It was good for a mobile service, right? This year on the 4G network, we're pushing around, that test was made at 878 megabits per second. Because from my point of view, yeah, speed is very fancy. This is marketing. This is cool. But more speed equals also being able to serve more customers, right? So, of course, if I have a very wide highway with cars going very fast, I'm going to serve more cars, right? I can serve them, and then they're going very fast. So speed equals serving more people. And it's important. Because what I'm showing you right now, it's the IoT figure, what we do project, Internet of Things. As we speak today, 2020, right, on all types of networks we have at Bell, we have about 30 million connected devices, all right? So my watch is connected, Wi-Fi or 4G. My phone is connected. I have my iPad. My car is connected 4G, right? So, and in shopping malls now you can buy thermostat and cameras and whatever, right? We think that in 5 years, the amount of connected object will grow by a factor of 10. So as we speak, the 4G network, the internet, all that, the mobile portion can handle all those connected devices. But growing a factor of 10 is not possible with this. We need to act right now to avoid congestion, right? Even cities are thinking about how can they be smarter, right? And connecting the cars is one thing, but traffic light, surveillance cameras, public transit, in every cities we'll see a boom of connected devices, not always transferring a whole lot of data, but managing those connections for a network is a lot, right? And that's an example I wanted to show you, that big picture. For an engineer managing the network, it's a stressing situation. We call this a mass calling event, right? So this is the Raptors parade last year, okay? Just like in a town, no road is designed to be able to handle a situation that happens, let's say, once every 5 or 6 years, right? So it's the same thing for networks. In that case, we could prepare in advance, like 4 days in advance, and crank up the capacity of the network before the Raptors parade. But we were at the limit, I would say. Some people saw a slight decrease in terms of connection speed, but calls could go through. It was okay. Think about what I just said. Traffic will go up by more than 200%, connected device. In 5 years, a situation like that would result in a network that congests. So there would be congestion, and the worst state of a congested network is when the 911 calls cannot go through, right? So 5G is able to handle more traffic, and also other cool features. We are able to slice a portion of the network, dedicate a portion of the network for, as an example, police, ambulance, and stuff like that, right? So it's future-proof, knowing the growth that we're seeing. All right. So let's continue with the what and the future. Let's talk about speed. Now, remember, I told you speed equals serving more people. As we speak today with LTE, or if you want the 4G network, we're able to pump or give up to 1.5 gigabits per second, right? That's the limit it can reach. All right. You heard we're deploying 5G right now. We call this the early 5G, at the early stage of 5G. Really, what we're doing, we're taking channels, frequency channels that we already own, and we're making this channel talk the 5G language. So just taking this technology, making it speaking a more evolved language, we can gain a certain percentage of increase. Roughly, it's about 10%, right? So this year, in terms of speed, not a big change, but we're changing the equipment. Now, somewhere end of next year, we will buy new channels, wider channel. This wider channel, more efficient because it's talking the 5G language, and a bit wider, will be able to get us to speeds around 3 gigabits per second. This channel that we're buying next year, it's what we call it, we call it the 3.5 band, okay? It's a frequency band, 3.5 gigahertz. It's not new. It's there since all the time. Maybe you know Wi-Fi as an example. So there's tens of thousands of Wi-Fi access points everywhere, and they transmit on the 2.4 gigahertz and on the 5 gigahertz. So that frequency that we'll be using is just in between, all right? But of course, with way less access point than Wi-Fi, but you know those frequencies, and they're here since a long time. Later on, technology will continue to evolve, and we will able to add new channels or new highway lanes, and ultimately, I don't know, 4 or 5 years, we want to get to 20 gigabits per second, which is pretty amazing, right? Now, how do we do that? All right. What I show here is the type of infrastructure we have to provide service. So in the 80s, we were putting a big tower a little outside of the town to give coverage. And after with the growth of usage, we started to use rooftops, a mix of towers and rooftops. And since, I would say, 5 years, 2015, we started to use smaller boxes, very low power. We call these the small cells. So we started to deploy these. So we kind of use a mix of all those, okay, actually. For small cells, it's really the same, almost exactly the same thing cities would do, as an example, when they deploy outside Wi-Fi coverage. It's just that it's talking another language, and it's using a frequency band that we paid for, right? It's just dedicated. All right. But deploying 5G right now is not putting hundreds of those more in outside. It wouldn't be affordable. What we do, in fact, is we use our existing sites. So this is a close-up on existing sites. On the left, you have a tower with the antennas on top and the equipment room below. Sometimes the antennas are not on a tower. They could be on a rooftop, right? The equipment room, really it's the brain, the computer that is inside the shelter. So it's controlling really every information exchange. We call these the BBU, really, the baseband unit. All right, and this baseband unit is connected outside to small boxes that we call the RRU, the remote radio unit that is outside. So these boxes that are very close to the antenna will generate the frequency, and we connect it to the antenna. All right, so that's a basic cell site. If I go on a close-up, so that's a picture on the left of a site that's on the rooftop in Trois-Rivières, a cell site in Trois-Rivières. We have equipment there since 20 years, right? And today, this week and today, we are deploying 5G there. How do we do that? What we're doing is that we take those RUs, so those radios here, those box, and they're transmitting actually a frequency we own in 4G. We remove that box. We put a brand new box that is almost the same, but it speaks the 5G language on the existing frequency we have. We connect it back to the antenna, and now we broadcast the 5G language. All right, and capable phones are able to connect to it. So really, as we speak, deploying 5G is using our existing infrastructure that is there since sometimes 10, 20 years, and changing a black radio or a gray radio for a yellow radio. All right. And the day we buy another frequency, we'll probably add another rack of radio just beside there. That's going to speak, as an example, 5G on the 3.5 gigahertz frequency, right? We may revamp the antenna, but it's basically the same site. So to summarize, 5G, it's not just about marketing, right? It's about handling the wave of traffic that's growing as we speak. It's a more efficient protocol or a wireless language to avoid congestion of information, right? Our network are the veins of society. We need to bring that information. We need to avoid that congestion. And finally, 5G is implemented in steps, right? Mainly by modernizing our existing infrastructure. So I hope this was useful to understand a bit the basic of that technology. Over to you.
Thank you very much, Yann, for your presentation. And I'm bringing back Noah Redler, President of Arche Innovation, for a question for you.
Thank you.
Hey, Yann. Thanks for the presentation. It was very informative. I think people learned a lot about what 5G really is today. But I think maybe the most important question for you is, for any of the municipalities watching us today, if they wanted to work with you and your team in Bell, Canada to start thinking about and planning their 5G network, what should they do?
You know, in our teams, we already have what we call the municipal relation primes. So in engineering, there's always a municipal relation prime that's going to interact with those municipalities, so they can reach out to them. I can put them in contact with these guys also, because whatever we do, it's very important to do it with municipal consent. It's mandatory for us.
Thank you very much, Yann. And I would also like to say hello to our friends from Bell Canada, our presenting sponsors who are with us in the audience today. And thank you for your support. Yann, thank you very much for your presentation. That's all the time that we have.
Thank you very much. Have a good day.